Okay, so we have an example on the board that we want to solve. We are going to be solving this together. So if I were you, I will pause this video and I will attempt solving this problem. I would love it if you can pause this video and attempt solving this problem with the knowledge you've already gotten about it. Attempt solving this problem. Then when you're done, come back to the video and see how to solve it. And then you score yourself and tell me what your score was in the comment section. Okay, back to what we are doing. We want to be able to solve this first example on set. This is a very beautiful example. The first, it says if P, which is a set containing 1, 2, 3, 4. So P has 4 elements, and Q, a set containing 3 elements, 2, 3, and 5, are subset of the universal set U, which is 1, 2, 3, 4, 5, 6, 7, 8. So they are subset of the universal set, meaning that their elements are gotten from the universal set. Now the question is now asking us to find A, P intersect Q, P union Q, P prime intersect Q, P union Q prime, P minus Q, and Q minus E. So this is intersect, union, difference of two sets. And you can see our complements. So we are touching everything now. So let's do that. Solution. Now to start, this is a very beautiful and simple example. It is in Sosta method. Our elements are clearly seen, so it's not an issue. So our elements are clearly seen. We can attack the question and we can solve it without issue. So to solve this, A, we'll start with A. We know what P is, we know what Q is. So we'll find out P intersect Q. P intersect Q is asking us to find what is common between P and Q. So we look at P, we look at Q. What is common between P and Q? I can see 2 here, I can see 2 here, I can see 3 here, I can see 3 here. Now those things that are in P and Q, whenever you see N, that small n means intersection. What is here, that is also here. What is here, that is also here. So now when we look at this, there's 2 here, there's 2 here, there's 3 here, there's 3 here. That means P intersect Q. It must be in a curly bracket. Is 2, 3. That's the intersection. Then for the second one, we are looking for P union Q. P union Q now is asking us, what would it look like if I combine P and Q together? Like marry them together, bring them together. That's union. That U means bring them together. So if I'm bringing it together, I like to arrange it. So it's going to be 1, 2, 3, 4, 5. Note, I did not repeat any elements. I did not repeat any elements. Then for the third one, we are looking for P prime intersect Q prime. Now, you are seeing a P prime. We have not seen P prime since we started solving this. We know P, we know Q, but we don't know P prime. So to answer this particular question, I must start by getting this P prime. So I look for what is my P prime. Now I know my P. I know my universal set. My P prime are those elements that are not in P but are in the universal set. So can we think of those elements? So in P we have 1, 2, 3, 4. 1, 2, 3, 4. If I exclude this, the other elements are my P prime. So that's going to be 5, 6, 7, 8. This is my P prime. So now I can go in straight to get P prime intersect Q. Now this is considering your P prime, your P complement, and your Q. See our Q, 2, 3, 5, and this one. So is there any relationship between P complement and Q? Is there any relationship between P complement and Q? What is common? I can see a 5 here, I can see a 5 here. So that's our answer. Did you get that? Then the fourth one, we are looking for P union Q prime, P union Q complement. Now just like this one, we don't know what is complement. So we have to start by getting what complement is. So Q complement is a set of elements that are not elements of Q but are in the universal set. So let's see, what is our Q? Our Q is 2, 3, 5. And now in partial set, if we remove 2, 3, 5, the others remaining, that's our Q inverse, Q complement. So that's going to be giving me 1, 4, 6, 7, 8. That's my Q complement. But the question said I should find P union Q complement. So where is my P? 1, 2, 3, 4. So I'm going to be combining it with what I just got here now. So that's going to be 1, 2, 3, 4, 6, 7, 8. So this is my P union Q. 1, 2, 3, 4, 6, 7, 8. I've combined P and Q complement together. Now for the next one, we want to get P minus Q. Now this is, remember, P minus Q, I said focus on the first set. Our first set here now is P. See our P and see our Q. So we're going to be considering what are those elements that are in Q, they are also in P. If we can find those elements, remove them from P. Whatever that is remaining in P, that's your answer. So that if I remove what are the elements in Q that are also in P, 2 and 3. If I remove them from P, what will remain? 1 and 4. So that's my results. For the last one, Q minus P. The elements in Q that are in, the elements of P that are also in Q. Q is coming first, so your focus should be on Q. So the elements in P that are in Q is 2 and 3. Remove them from the first element, which is remove them from the first set. That's Q. If I remove 2 and 3 from Q, what will remain? 5. That's the result I'm writing. Please don't make the mistake of going to combine the two things remaining. So instead do that, you're not saying that Q minus P will be 1, 4, and 5. That's very wrong. That's very wrong. Your Q minus B is just the elements of Q that are remaining after you have removed any element that belongs to P. And I hope you got that. So this was nice. In our next video, we are going to be doing a second example.